So, a boiler's oil system, also known as an oil-fired boiler system, is a heating system that uses oil as its primary fuel source to generate heat. This type of system is commonly found in homes and industrial settings where access to natural gas may be limited or where oil is preferred fuel source. Here are overview of how typical boiler of oil works. First is fuel storage. So the system begins with a storage tank that holds the heating oil. This tank is typically located either inside or outside the building. The tank may be above ground or buried underground, depending on local regulation and preferences. So the next is fuel delivery. Heating oil is delivered to the storage tank by a fuel delivery truck. The frequency of the deliveries depends on the size of the tank and the heating needs of the building. So next is the fuel transfer. From the storage tank, the oil is pumped to the boiler unit. The pump ensures a consistent and controlled flow of oil to the burner. Combustion. Inside the boiler, the oil is burned in combustion chamber. This generates heat which is used to heat water or produce steam. The specific design of the boiler can vary, but the basic principle involves igniting the oil, mixing it with air and allowing combustion to occur. Next is heat distribution. So once the oil is burned, the heat energy is transferred to a heat exchanger or a coil. In a hydronic heating system, so water circulates through the heat exchanger and it is heated by the oil fired burner. So in a steam system, the heat is used to generate steam, which is then distributed throughout the building via pipes and radiators.
Temperature control. To maintain a comfortable indoor temperature, the boiler system typically includes control and thermostats. This device regulates the burner operation to achieve the desired temperature in the building. When the thermostat detects a need for heat, it signals to the burner to start or stop as necessary. The exhaust. The combustion process produces exhaust gases which contains byproducts such as carbon dioxide and water vapor. These gases are vented safely outside the building using flue or chimney. Maintenance. Regular maintenance is essential to ensure the efficient and safe operation of an oil-fired boiler system. This includes cleaning and servicing the burner, inspecting and cleaning the heat exchanger and coil, and checking for any leaks or issues with the fuel storage tank. It's worth noting that while oil-fired boiler systems are still in use in many areas, there has been a growing shift toward cleaner and more energy-efficient heating alternatives, such as natural gases, electric heat pumps, and renewable energy source. Additionally, improving the energy efficiency of existing oil-fired systems through upgrades of insulation can help reduce their environmental impact and operating costs.
Good day, sir. We are Group 1 and we will be discussing about feed water system, steam service system, and boiler fuel oil system. So let's start with feed water system. So when we say a feed water system, so it is a crucial component of steam boilers and power plants. Its primary function is to supply clean and treated water to the boiler, ensuring efficient and safe steam generation. The feed water system plays a vital role in maintaining the integrity of the boiler and preventing issues such as corrosion, scaling, and overheating. So here are the main components of a feed water system. first is feed water tank or aerator. Second is feed water pumps. Third is chemical treatment system. Fourth is heating elements. Fifth is control and monitoring equipments. And lastly, the safety devices. So, the overall function of a feed water system is to ensure that the water supplied to the boiler is of high quality, properly treated, at the right temperature and pressure, and free from impurities that could lead to damage or reduced efficiency in the boiler. Properly treated and conditioned feed water helps prolong the life of the boiler, minimize maintenance requirements, and maximize the efficiency of steam generation in power plants and industrial processes. So, that's all for the feed water system, and my groupmates will discuss the rest.
So the topic is steam system service. So what is the steam used for? So steam systems are commonly used in industrial, commercial, institutional, power, and process applications to supply heat or turn turbines. The development of steam system dates back to 18th century. So, what are the typical steam system? So, the most common device used to produce steam is that which burns a fuel, which in turn boils water under the pressure to produce steam. Stationary boilers powered industry and ships, while movable boilers became steam locomotives. So, why was steam so important? So, steam power became the energy source for many machines and vehicles. So, by making it cheaper and easier to produce commodities in large amounts. So, this is a turn increased the demand for raw materials used to build more machines that can produce even more commodities. And the next one is the also the steam system services has benefits. So steam system services can help to maintain your steam system at its own optimal level, ensuring the steam reaches the point of use at the correct quantity, quality, and pressure. These are the increased turnover. It reduces downtime through preventative maintenance, reduce product rejects by ensuring steam reaches point of use at correct conditions. And also, it has a good effects in health and safety, helping you comply with regulations and legislation.
Okay, my name is Japp Alvarez, and I will talk about the feed water system. So the feed water system is a critical component of a steam power plant, such as thermal power station or a nuclear power plant. Its primary function is to supply purified water to the boiler, where it is converted into steam to drive a turbine and generate electricity. The feed water system plays a crucial role in maintaining the efficiency and safety of the power generation process. Here's the explanation of the key components and the functions of a typical feed water system. So first, let's talk about water source. The feed water system typically begins with a water source, which can be natural water body like a river or lake, or it can be treated and purified water from a municipal source or a dedicated water treatment facility. So next is intake structure. If the water source is a natural body of water, there is usually an intake structure designed to draw water into the feed water system. Next is pre-treatment. Before entering the boiler, the feed water goes through a series of pre-treatment processes to remove impurities. Next is feed water pump. So, feed water pumps are used to pressurize and transport the treated and dehydrated water from the pre-treatment and stages to the boiler. These pumps are critical for maintaining the proper flow rate and pressure in the system.
Next is the boiler. The feed water is injected into the boiler, where it is heated to high temperatures by the combustion of fuel or by the heat generated from nuclear reactions. The heat energy turns the water into high pressure steam. So next is steam drum. In many boiler systems, there's a steam drum where steam water and water are separated. Next is the condenser. After passing through the turbine, the steam is condensed back into water in the condenser. And next is chemical treatment and monitoring. Throughout the feed water system, chemical additives and monitoring system are used to ensure water quality and prevent corrosion, scaling, and other issues. Next is cooling water system. Some power plants use cooling water to remove excess heat from the condenser. So, in summary, the feed water system is a critical part of power plant's operation, ensuring that high quality water is continuously supplied to the boiler to produce steam and generate electricity efficiently and safely. And proper maintenance and water quality control are essential to the longevity and performance of the entire power generation system. That's all. Thank you.